How is it that we can expose metals like copper and aluminum to lots of energy to cook our food, but when the lithium-ion batteries powering our devices malfunction, they can overheat and explode? Well, it has to do with where these metals are on the periodic table of elements, which is organized based on common characteristics. We can determine patterns in element properties by studying specific reactions. Let's observe what happens when we place aluminum, magnesium, and calcium metal in vinegar at the same time. We can see that the test tube with calcium metal on the right starts to fizz immediately. The test tube with magnesium metal in the middle fizzes a little. Nothing appears to be happening with the test tube with aluminum metal on the left. The color change is due to phenolphthalein, an indicator that turns pink in the presence of a base. We can see that aluminum was the least reactive metal and calcium was the most reactive metal. Magnesium and aluminum are in the same period, so the reactivity of metals decreases going from left to right. Magnesium and calcium are in the same group, so the reactivity of metals increases going from top to bottom. But why does this happen? Remember, metals lose electrons in order to obtain a noble gas electron configuration. Calcium has the largest radius of the three elements. This means less energy is needed to remove an electron from calcium. Since it is easier for calcium to lose electrons, it is the most reactive of the three metals. Aluminum, on the other hand, has the smallest radius of the three elements. Since the aluminum nucleus is hanging onto its electrons more strongly, more energy is needed to remove an electron from aluminum. Since it is harder for aluminum to lose electrons, it is the least reactive of the three metals. Now that you know the general trend for the reactivity of metals, you can explain why lithium can be dangerous in batteries, why copper is a safe choice for electrical wires, and predict the reactivity of other metals.